All right, our last lesson for this unit is the Earth's crust. We're going to describe the characteristics of the Earth's crust, and then we're going to compare continental and oceanic crust, which will be important again in the next unit. Okay, so the crust is a thin outermost layer. It goes from 8 to 32 kilometers. You can add that to your notes here so that you have that. We've been talking about that all along, that the crust is going to vary depending upon whether it's oceanic or whether it's mountains. That'll impact how thick the crust is. It's thinner than any other layer. All life exists on or within a few hundred meters of the crust. So you can only go so far down into the crust to find life, and you can only go so far above the crust in order to find life. Most of the crust cannot be seen because it's covered with soil, rock, and water. So we don't really count the water, the soil, as being part of the crust. The crust is made of 3 types of rock: igneous rock, which forms when lava or magma cools and hardens; sedimentary rock, which forms when sediments or small pieces of rock and sand are pressed and cemented together by the weight of layers built up over long periods of time; and metamorphic rock. Metamorphic rock is formed when igneous and sedimentary rocks get basically buried even further than the sedimentary rocks. They undergo heat, pressure, or actions of chemicals can also cause metamorphic rock to form. We're not going to get too worried about these 3 types of rock yet. It's good to kind of at least get an idea of how they form, but we'll be talking about those hopefully later this year. Thickness of the crust varies. The oceanic crust is less than 10 kilometers thick, which makes sense because you've got water over top of it, so you're not going to have as much of a crust there as you do on land. The oceanic is made of silicon, oxygen, iron, and magnesium, and it's under all the oceans. Continental crust is going to be thicker because it's staying above water. It's typically 32 kilometers thick on average, so it could be more or less. It's made of silicon, oxygen, aluminum, calcium, sodium, and potassium. And it is under all the landforms, it includes the continents, the land. And this just kind of shows the percentage in the crust of all the different elements. Here we have our composition and temperature of all the different layers. So you can see our solid core, our solid inner core, our outer core. We've got what they're made of, our temperatures, our kilometer differences. This would actually be a very good reference for one of the assignments that you'll be doing. Includes all the elements, degrees. So that's a good reference for you to use. Another thing with the Earth's surface, so we can get diamonds from the upper part of the Earth's mantle. Diamonds only form when there is a huge amount of pressure. Pressure has to be 65,000 times the pressure at the Earth's surface. Temperature has to be close to 1500 degrees Celsius. Carbon can get transformed into diamonds, and diamond-laden molten rock is forced to the surface by volcanoes. So that's how we can get access to it, because otherwise it's way below ground. So 65,000 times the pressure would have to be like pretty deep in the earth. And then so when it does get pushed to the surface by volcanoes, or if we have some uplift, there can be mines cut into the crust to expose the diamonds that formed. So that's just something interesting with the whole process of rock cycle, so on and so forth.